So I think the best way to do this question is to keep everything involving ratios. We've got A to B to C. And first up, I've got A to B is 2 to 3, and A to C is 3 to 4. So if I can make these two the same, then I can also compare B and C together. So I'm going to times the top ratio through by 3, give me 6 to 9, and the bottom ratio by 2, because that will give me 6 to 8. And there we go. I can write A to B to C as a single ratio. So what's the ratio of B to C? The answer is going to be 9 to 8, D. Great. I'm just going to go through this question in one other way, not because it's a good method here, but because it would be useful potentially in other situations. We actually have a ratio equation here, and you can go from a ratio equation to a fractional equation. Because here's an example. Let's say I've got the ratio 2 to 3. Well, that's equal to 4 to 6 if I multiplied through by 2. If I wanted to get my scale factor, then I could do 4 over 2, but I could also get the scale factor by doing 6 over 3. And you can see I've gone from a ratio equation to a fractional equation. I could also do it the other way around if I wanted. 2 over 4 is 3 over 6 if I was kind of going back the other way. And what I'm trying to say is that I could write down from here that A over 2 is B over 3. And from that, 3A equals 2B. You can just do that when you have these sorts of equations. I'd say take a bit of time with it and make sure you understand it, but there we go. And if we carry on with A to C equals 3 to 4, we can do the same kind of thing. We can say that 4A is 3C. So remember, I want to get a comparison between B and C. So I could make A the subject. A is going to be 2/3 B, and A is going to be 3/4 C, which means 2/3 B, I should say, is going to equal 3/4 C. Multiply through, I'm going to get 8, like cross multiply, 8B is equal to 9C. And from that, we can kind of work backwards and say B to C is going to be 9 to 8. Kind of just go in the opposite way to how I went from here to here. I think it can be a little bit complicated sometimes using this idea. Just be really careful with it, but there will be times when it would be important to go from ratio equations to fractional equations. So that's why I give it as a second method here.